How does climate change impact the potential of renewable energy in Antarctica? Have you ever wondered how climate change could reshape the future of renewable energy in one of the coldest places on Earth? Antarctica is not just a land of ice. It is also a region with growing potential for renewable energy sources. As the climate changes, it brings both challenges and opportunities for harnessing energy in this unique environment. Climate change is altering the environment in Antarctica, affecting how renewable energy can be developed and utilized. Traditionally, the extreme cold and long periods of darkness have made it difficult to rely on renewable sources. Most energy supply has depended on fossil fuels like diesel. However, there is a shift happening. Research stations are increasingly adopting renewable energy sources such as wind, solar, and geothermal to lessen greenhouse gas emissions. One significant impact of climate change is the change in wind patterns. Wind energy is a major resource in Antarctica. As climate change modifies wind speeds and patterns, this directly influences the efficiency of wind turbines. Some areas may experience stronger winds, which could enhance energy generation. However, other regions might see a decrease in wind intensity, which means adjustments in turbine design and placement will be necessary. Solar energy is another area affected by climate change. The 6 months of polar night limit solar power availability. However, changes in cloud cover and atmospheric conditions could influence solar radiation levels during the daylight months. Interestingly, as ice and snow melt, the surface reflectivity may decrease, potentially increasing solar absorption and improving the efficiency of solar panels in certain locations. Temperature changes also play a role in how renewable energy equipment operates. Warmer temperatures could reduce the challenges posed by extreme cold, such as freezing mechanical parts or battery inefficiencies. However, increased variability and extreme weather events may require stronger infrastructure to handle harsher conditions. Moreover, melting ice and thawing permafrost can impact the stability of foundations for renewable energy installations. Infrastructure development must adapt to these changing ground conditions. On a positive note, reduced sea ice could improve access for transporting renewable energy equipment and maintenance crews, making deployment easier. Geothermal energy presents another exciting opportunity. As climate change thins ice sheets, new geothermal hotspots may become accessible. While geothermal energy is less developed in Antarctica, it holds promise as a renewable source that could work alongside wind and solar. Several research stations in Antarctica have already implemented renewable energy systems, showcasing their viability. For instance, the Belgian Princess Elisabeth station operates entirely on solar and wind energy, achieving zero emissions year-round. This station uses energy storage and smart management systems to maintain power even during the dark winter months. On Ross Island, a wind farm with 3 turbines generates up to 1 megawatt of power, supplying energy to New Zealand's Scott Base and the United States McMurdo Station. This significantly reduces diesel consumption and highlights the potential of wind energy in the region. Advancements in battery storage and smart controls are also making it easier for bases to balance intermittent renewable sources, despite the continent's challenging environment. In summary, climate change impacts the potential of renewable energy in Antarctica by altering environmental conditions that affect wind and solar resources, equipment performance, and infrastructure stability. While these changes present engineering and logistical challenges, they also create new opportunities to expand renewable energy use. Transitioning to renewables in Antarctica supports sustainability goals and reduces carbon footprints in this sensitive ecosystem.